This video is on the objective: determine the p-value for a hypothesis test for the difference of two means, or difference of two population means. And this is with the population standard deviations unknown. So you're going to eventually be using a student's t distribution with so many degrees of freedom. And let's take a look at the question. And if you're unfamiliar with the topic, would like to see more about it, what they have to say on it, click on more instruction, look at their videos, their notes, their examples, and hopefully they help you. Alright, so it says here, Quinn Napoli is looking to purchase a vehicle and is deciding between two models, the Glacier and the Ravine. One of Quinn's friends suggests to her that perhaps the annual maintenance costs are different for the two models. So she obtains random samples of the annual maintenance costs for 50 owners of each car model, right? So 50 Glacier owners, 50 Ravine owners. The results are provided in the table shown below, right? Your Glacier sample, your Ravine sample. Let mu1 be the population mean annual maintenance cost for the Glacier, and let mu2 be the population mean annual maintenance cost for the Ravine. Quinn assumes the population standard deviations are not equal. Right, so this assumption that the population standard deviations are not equal means it's a non-pooled t-test, right? And the number of degrees of freedom of the t-distribution would be the smaller sample size minus 1. So they're both 50 though, so 50 minus 1. And you see how they're saying here the degrees of freedom is 49. So we don't need to do all, they already gave us all this. And tests the alternative hypothesis, that mu1 minus mu2 is not 0, meaning that the mean annual maintenance costs for glaciers and ravines are not the same, is what this alternative hypothesis is saying. All right. If the test statistic came back as a t-score of negative 1.55 for the difference in these sample means, negative 1.55, and the number of degrees of freedom for the t-distribution is 49, what is the p-value for this hypothesis test? All right, so again, I'll go to a piece of paper, write some of this stuff out. We'll draw a picture. So, right, the null hypothesis would then be that mu1 minus mu2 is equal to 0, right? Because they told us the alternative hypothesis was that that is not equal to 0. Right, so this statement's saying that the mean maintenance costs for the glaciers and ravines are not the same. What we would do for the test is we'd assume that they are the same. Right? Assume that mu1 minus mu2 equals 0. And then later on, once we've calculated the p-value and compared that to alpha, which wasn't given here, right? Alpha, the significance level, isn't given. And if it's not given, you can usually assume 5%, right, for the value of alpha for most tests. All right, and then hypotheses, significance level, they gave us a test statistic. All right, the test statistic, the t-score for the difference in our sample means came back at negative 1.55. Right. And they've also told us that the distribution of the difference in sample means, that x1 bar minus x2 bar, has a student's t-distribution with 49 degrees of freedom. And I'll draw this. So you have a horizontal axis here representing t-scores. T-distribution's a bell-shaped symmetrical distribution similar to a normal. underneath the peak is a t-score of 0. And we're finding p-value. Now for p-value, you just need to know where the test statistic is. And that comes up at negative 1.55. Right, there's the test statistic. Now this is a two-tailed test. Right? That's what the alternative hypothesis shows us. We have the parameter not equal to a value. And what kind of a test you have, right, determines how to calculate the p-value. Now, if it were just less than 0, this alternative hypothesis, it would just be a left-tailed test, and the p-value would simply be the area to the left of my test statistic. If it were greater than 0, it would be a right-tailed test, and the p-value would be the area to the right of my test statistic. But the not equal to the two-tailed test, and I did this in the first video on this objective as well. For the p-value here, my test statistic is to the left of center. So I take the area to the left of my test statistic, and this is going to be half the p-value. So for the p-value, I take this area and double it, right, for a two-tailed test. So the p-value is this area times 2. All right, so you can think about it that way, or an equivalent way of thinking about it, it means the same thing. I find the area to the left of negative 1.55, my test statistic, and then the doubling it could be the same as this. I look at the positive 1.55, I look at the positive version of my test statistic, and find the area of the right tail as well, right? the area to the right of that, and get my two tails. And both these areas combined make the p-value. Alright. Now I could find this with the calculator. I got the calculator pulled up already. And you were finding area under a t distribution with 49 degrees of freedom. So I go to that distributions area and down to TCDF. Right, number 6, that's area under a t-curve. Now I'm trying to find this area to the left of my test statistic first, negative 1.55. So there is no, the lower value, I'm going to put some big negative number like I have up here already, negative 99999. Then the upper value is my test statistic, negative 1.55. And the degrees of freedom was 49. Right, so I enter this, and this area is a little over 6%. Right, so this area, the area to the left of my test statistic, is approximately 0.064. And that means so with this area, right? The area to the right of positive 1.55 would be approximately 0.064. And then putting those together, right, the two tails, gives me my p-value. So the p-value, and I'm just going to go double this, times 2 on the calculator. It's about 0.128. 0.128 is the p-value then for our test statistic. Right. And then if you look at the options, this is greater than 10%, this is 12.8%. Look at the options, our p-value is greater than 0.1, right? So that's that fourth option. Now if you were to use the table, we were looking at a t-distribution with 49 degrees of freedom. So it's this row here. And our test statistic was negative 1.55, but these are all positive values. So let's look at where positive 1.55 would fall. Let's see, I got 1.299, 1.677. 1.55 would be between these two. So that means the area to the right of 1.55 would be between 5% and 10%, but then you got to double that, because it's a two-tailed test. So between 10 and 20%, which, I said the p-value using my calculator was 12.8%. That's definitely between 10 and 20, or greater than 10. Right? So you can use a calculator, read the table, whatever. Right? Now be careful, right? I only doubled this stuff because it was a two-tailed test. If it were a one-tailed test, you wouldn't double anything. Right? If it were just a right-tailed test or just a left-tailed test. So just pay attention to the alternative hypothesis and what kind of a test you're running. And again, read your answer explanations. And hopefully these answer explanations and my videos and the more instruction, whatever you're looking at, hopefully all this stuff helps you, when you're working on this stuff on your own. And thank you very much for watching.